So it would look something like this because you'd come down to the very bottom and then you'd go up in the air again, you'd come back down to the bottom, you'd go up in the air again, you'd come back down, you'd go up in the air again, you'd come back down. This is what your height would look like over time because you'd be going up in the air, going back to the bottom, going up in the air, coming back to the bottom. You'd be going in a circle, but if we looked at the graph of your height in the air as time is passing, then as time is passing, you're going down, you're going up, you're going down, you're going up, you're going down, you're going up. Does that make sense how you're going in a wave-like motion, even though you're going around in a circle because you're going up and down? Okay. So if we look at the information they gave us, they say that the very top, the very highest height that you go is 84 feet. The very lowest height that you're at is 4 feet, which makes sense because they say that the diameter of the wheel is 80 feet. Does that make sense? So the very lowest is 4, the very highest is 84. They said that it takes you 6 seconds to reach the top. So right here in the middle, this is going to be 6 seconds. So how long would it take you to complete one full rotation? 12 seconds, okay. All right, so we've got that. And then can anyone tell me what the midline of this graph would be? What's the middle? The top is 84, the bottom is 4. 44. Okay, so the midline of this graph is 44. Okay, so if we wanted to find the midline, we could do 84 plus 4 divided by 2 is 44. So the highest point plus the lowest point divided by 2 gives us the middle, right? The middle is just the average. And that's how we find average. We add the two numbers together, divide by 2. Okay. Now, if we look at this, and if I trace just one cycle of the graph, if I trace from here to here, does that look like a sine curve or a cosine curve? Cosine. They both look like sine and cosine curves, right, if you trace out the whole thing. But if we look at just this beginning part, this looks like a cosine curve. Does it look like a positive or a negative cosine curve? Looks like a negative cosine curve because it starts down and it ends down. Does that make sense? So if we write the equation for this, we're going to get a negative cosine graph. Okay. So if we look at this, we can see some information about the graph. We can already tell what the amplitude of the function is. Anyone know what the amplitude would be? Not 80. What's the amplitude? 40. Perfect. So from here to here is 40. From here to here is 40, right? From the very bottom to the very top is 80. But from the middle to the bottom, from the middle to the top, that's 40. So the amplitude is 40. We already know the period of the graph. The period is 12. Let's go ahead and figure out what the b value would be. So we know that 2 pi divided by b is 12. That's the whole period of the graph. So how could we solve for the b value? Multiply the b up over here. So I'm going to say 2 pi equals 12b. And then what should I do? Divide by 12. Okay, so 2 pi over 12 equals b. So pi over 6 equals b. So that's going to show up in the equation somewhere. Okay, question 2. So we're all set up now. We've found all the pieces. When we get down to number 3, we're going to be able to write the equation. Question 2 says, what is the period of the function? We already know that the period of the function is 12. What does this mean in the context of the problem? Yeah. So it takes 12 seconds to do 1 revolution on the Ferris wheel. Does anyone know the history of the Ferris wheel? Because if you type this, it will always capitalize the F, which makes me think it's a name. Is it named after somebody? Somebody Ferris? I'm assuming. I don't know. It was driving me crazy when I was typing it. I was like, a Ferris wheel, that's a thing. Lowercase that, but it kept capitalizing it. All right, it takes 12 seconds to do 1 revolution on the Ferris wheel. Okay, now we're going to write a sinusoidal function. Remember, that doesn't have to be sine, it could be cosine, which is what it's going to be for this case. So we're going to say y equals, and then how should we start this equation? With the amplitude? 40. What kind of 40? Positive or negative? Negative, because it starts down. Okay. Sine or cosine? Cosine. So it starts down, ends down. Remember, sine is in the middle. Starts in the middle, ends in the middle. All right, so this one starts down, ends down, which makes it a cosine graph, okay? Negative 40 cosine, all right. What do we have in front of the x value? Pi 6, okay, pi 6 goes in front of x, all right. Has this graph been shifted to the right or left? No, starts right at 0, okay, so we don't have to have parentheses on this one. And then what goes next? Plus 44, because that's the midline. Okay, so now if we want to check our work, we just want to make sure that what we got was accurate. What we can do is we can plug in a time of 6 and make sure that at a time of 6 that the height is 84. Does that make sense? Make sure at a time of 6 that the height is 84. Okay, when we plug in these numbers, when we plug in a time of 6 to make sure the height is 84, when we get down to question 4 and plug in 4 seconds, plug in 10 seconds, do you guys want to do it from the graphing screen or do you guys want to do it from the calculator screen? Calculator screen? Okay, so what we're going to do is we are going to store the number 6 in our calculator for x. So we're about to plug in 6 and just make sure that 6 gives us an output of 84. So I'm going to hit the number 6. And then down here where it says STO, I'm going to store 6 as x. I'm going to store 6 as x. So this is what I just typed on my screen. 6 is being stored as x. Press enter, and now if you hit the X key and press enter, it will output a 6. So it's going to plug in a specific value for X for you. Everyone good with that so far? Okay. Now what I'm going to do is I'm going to type in my equation with the X in it. So I'm going to type in negative 40 cos, and remember we are in radians because we all cleared our calculators when class got started, right? So our calculator default goes into radians. We want to be in radians because we did pi 6 when we did 2 pi over b for the period when we used that formula. That means that we were doing radians. When we have the pi 6 here, that means we're in radians. So it's correct that our calculator should be in radians. Pi 6 times x, now this is me plugging in the 6 for x, that's what I'm doing right now, plus 44. And if we did this correctly, then when we plug in 6, our output should be 84, that height. And that means we did it correctly. We got the correct equation. Okay. We feel good about that? Okay, so we just verified our equation is correct. Now let's answer the question, how high in the air were you after 4 seconds? So what I'm going to do now is I'm going to take 4, I'm going to store 4 as x now. 4 stored as x. And I'm going to go up here and I'm just going to take this equation, I'm going to copy paste it. And this time it's going to take the equation, but it's going to plug 4 in instead. So copy paste, press enter, see what my new value is. And what did you guys get? 64. If I plug in 4, I get 64. Okay. So I'm going to say take the function, plug in 4, you get 64. You are 64 feet in the air. After 4 seconds. Okay, I'll go ahead and I'll do the same thing with 10. So I'm going to take the 10 and I'm going to store it as x. And then I'm going to go up and I'm going to grab that equation. I'm going to copy paste it. And then I'll see what it equals. And what do you guys get? 24. Okay. Does that make sense? Yes? Okay. All right, now the next problem is just a smidge more complicated. You'll see in the wording of it that they change things up a little bit from this one. So let's flip the page over. We're doing a Ferris wheel problem again. So it says, as you ride the Ferris wheel, your distance from the ground varies sinusoidally with time. Same thing as before. You are in the last seat filled, and the Ferris wheel starts immediately. Same thing as before. Let x be the number of seconds that have elapsed since you got on. You find that it takes 3 seconds to reach the top, 43 feet above the ground. The diameter of the wheel is 40 feet. The wheel makes a revolution once every 8 seconds. So if you think about this, the math does not make sense, okay? So it says it takes you 3 seconds to reach the top, but every revolution is 8 seconds. It takes you 3 seconds to reach the top, but every revolution is 8 seconds, okay? So if we picture this, it takes you 3 seconds to reach the top, but a full revolution is 8 seconds. Did you get on at the very bottom? No, you did not. You got on somewhere over here. So this is an example of a Ferris wheel where the platform of them loading you on is not at the bottom. The platform is off to the side and is a little bit higher. Does that make sense? They're not loading you at the lowest point. They're loading you at a slightly higher point. Okay? So it's going to make it so we have to adjust our drawing. Okay, so let's go ahead and do that. So I'm still going to have my x and my y axis. I still have my x-axis as time. I still have my y-axis as height. Now when I do this one, you can kind of compare it to what you did before. Instead of getting on at the lowest point, we're going to get on somewhere like right here. Okay? So it's not our lowest point this time. So I'm going to think of it like right here. I'm getting on at a slightly higher point, and then I go up in the air, and then I come down. Okay, so see how I'm coming down lower, and then I'm getting up in the air again, coming down again. Okay, so I know that the full revolution right here, I know that the full revolution is 8 seconds, but Let me kind of draw this. There we go. Okay, so this is the bottom of the Ferris wheel. This is where I got on. Does that make sense? I didn't get on at the bottom. Okay, there's the top right there. I know that the top is at 3 seconds. Okay, so what I'm going to do is I'm going to trace this past here a little bit. There's the bottom of the curve over there. Does that make sense? Okay. Does anyone know what number over here would have the bottom of the curve? -1. How do you know it would be at -1? Yeah, so, but it wouldn't be at -1, because 3 to 8 is how many spaces? 5. So it'd be -2. Makes a full revolution once every 8 seconds. No, we still have to, hold on, we have to think about this. Makes a full revolution every 8 seconds. That's not 8. Hold on, that's not 8. It makes a full revolution every 8 seconds. You were right, it is -1. Hold on, we have to think this through. It makes a full revolution every 8 seconds. From our starting point to this is where the 8 would be. Okay, there's our full revolution. You were exactly right. That was a good catch. Okay, so if it makes a full revolution, it would be from the starting point to the finishing point. This would be 8 seconds. Does that make sense? Okay, so from here to here would be 8 seconds. So Miriam was exactly right when she said -1. She was exactly right. Does that make sense? So the whole revolution is every 8 seconds. So from our starting point, from where we would start, because our whole revolution wouldn't be from the bottom to the bottom, our whole revolution would be a step up to a step up. So we would say our whole revolution would be from like here to right here. Does that make sense? So that was, whew, I almost led you guys astray, but it took me a second. Miriam caught it though. Okay, so we got -1 to 3, and then the bottom right here, where would that actually be at? It would actually be at 7, yeah. Okay, so -1 to 3, and then 3 to 7. So a whole revolution would be 8 seconds. Okay, so we've got the highest point on the graph is, or the highest point for the Ferris wheel is 43 feet above the ground. The diameter of the Ferris wheel is 40 feet. So what's the very lowest point? 3 feet. Okay. And then what would the midline be? 23. Okay. 23 feet. Okay. We know that the period of the graph is the 8 seconds that makes a full revolution. So 2 pi divided by b is 8 seconds. And then what should we do? Multiply the b over 2 pi equals 8b. Divide by 8. And so b equals pi over 4. Okay. So we have our b value. Oh, what's our amplitude? Not 23. Not 40. 20. Okay. So 20, 20, okay. Our midline is 23, okay. So we're going to write our equation, Okay, I'm going to go ahead and draw the part that we're using. Okay, so our equation is y equals, and then what do we have? Negative 20 cos Now, has this graph shifted to the left or the right? Yes, this graph actually has shifted to the left because we are not getting on the Ferris wheel at the lowest point. So the start of the cosine graph is actually over here instead of at 0, which means that the graph has shifted to the left. So I'm going to put parentheses and parentheses, and it would be x plus 1. Okay? And then what belongs on the very end? Plus 23. Okay, so what I'm going to do now is I'm going to store a number as x so that I can check my work and make sure my equation is correct. And what should I plug in to make sure my equation is correct? What would be easy to plug in and make sure? I could plug in 3, and if I have an input of 3, what should my output be? 43. At 3 seconds, I'm at the very highest point. Okay, so I'm going to do 3, store it as x. Okay, and then I'm going to type in my equation and just make sure that my output at that point is 43. And as long as my output is 43, that means that I did this correctly. And what are you guys getting? 43? Marvelous. Okay, so let's do the rest of it. How far off the ground are you after 6 seconds? So what should we do? Okay, 6 stored as x. I'm going to go back up. I'm going to copy paste my equation. And what do you guys get? Is it a decimal? Okay. So let's do 3 decimal places. We're going to say if I take my function and I plug in 6, I get 8.858. So you are about 8.858 feet off the ground after 6 seconds. All right, the next one says, at what time are you 18 feet above the ground? So can we just plug in 18 for the x? No. What do we have to do? We can graph it. So 18 goes in for which coordinate? The y coordinate. So for this one, if I want to use my calculator, I'm going to have to graph it for this one. So I'm going to type in negative 20 cos pi fourths x plus 1 plus 23. And I know approximately what my window should be because I've got this right here. I drew a little sketch of my window. So I know that my x window needs to at least go to 7. My y window needs to go to at least 43. So once I'm done typing that equation, I'm going to hit the window button. For my x, I'm good. This goes to 10, so that's fine. I'm going to make this -1. So I'm going to go from -1 to 10. Scaling by ones is fine. Do you guys want to scale by ones, so have little lines at every one? Negative 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you guys want to do that? Keep it at ones? Okay. For the y's, I'll go from like -5 to 45. And then for my scale, if I go by ones, that's a lot of little lines along the y-axis. So I think I'm going to go by 5s so that it doesn't do as many little lines. Okay. Now this is not ready to solve the problem yet. This is just so that I can see the graph. So there's our coast graph. Okay. And now if we want to see at what time are you 18 feet above the ground, we're going to hit the y equals button again. We're going to go down to y2 and we're going to type 18. So 18 feet above the ground, 18 is the y coordinate, so we're going to type 18. And there's a couple different places where that happens. So we can just do the first couple. We can do it with the first rotation. Really, I should have worded this better. So it should have said, at what time are you 18 feet above the ground in the first rotation? Or in the first 3 rotations, it should give you a time frame to look at in reality, which if I was doing a testing situation, I would. So let's go ahead and find these first 3. So we're going to do second trace. And then how do we find those answers? Intersect. Okay, number 5. All right, so if I want this intersection over here, I'm going to hit my left arrow. I don't have to be right on the intersection. I just have to be closer to this intersection than to the other ones. So I'm closer to this one, and then I press enter, enter, enter. Okay, and it'll find it. So I'm going to use 3 decimal places, so 0.678. 0.678. Okay, and then I'll do it again. Second trace, number 5. I don't have to be on the intersection, I just have to be closer to that one than the other 2. So right here is my cursor. Enter, enter, enter. It's going to find this one. 5.322. Okay, can find the next one. Second trace, number 5. Enter, enter, enter. 8.678. Okay. What I want you to do is I want you to take a moment in your groups and I want you to picture this Ferris wheel and I want you to figure out where you would have to get on the Ferris wheel to have a cosine equation that was positive and not negative. So talk in your groups for a minute. We had just had 2 negative cosine equations. Where would you have to get on the graph, or where would you have to get on the Ferris wheel to have a positive cosine equation instead of negative? Okay, go ahead and talk about that for a minute. Okay, do we have an idea? Where would you get on the Ferris wheel to have a positive? We'd have to get on at the top. So if you get on at the top of the Ferris wheel, then you would start up here at the top, and you would go down first, and then you would come back up, and that would be a full rotation. So at the top, you'd go down and then come back up. Okay? Take another moment and talk. I want you to figure out where would you get on the Ferris wheel to make a sine curve instead of a cosine curve. So talk about that. Figure out where would you get on the Ferris wheel to make a sine curve instead of a cosine curve. Okay, what would make a sine curve? The middle. This middle? What would this one do if you got on at this middle? It's a sine curve, but what kind? Negative, because you'd be going which direction first? You'd be going down first. So if you started here, you'd be right in the middle, but you'd be going down first. And do sine curves usually go down first? No, that's the opposite for a sine curve. So you'd be going down first, and then you'd be going up. That's what would make it the opposite version. If you start over here, you'd be going up first and then down. Does that make sense? Okay. So Ferris wheels can be either sine or cosine, but since you typically get on a Ferris wheel somewhere near the bottom, it's usually a negative cos graph. Doesn't have to always be a negative cos graph, but usually it's going to be because of the way we get on them. Okay, so I'm going to go ahead and give you the practice assignment. The first several problems are Ferris wheel problems, and then once you get kind of okay with that, then it gives you some other scenarios. So let me know if we get kind of stuck on those.